Today we're talking about 5.19 variables. Variables are basically the thing that we don't know. First, let's look at the multiplication division table right here. I want to pay particular attention to right here, 8.4. That means multiplication. No longer will we use 8x4. You may see it from time to time, but we're going to try to break away from it looking like this, mainly because we're doing variables. And in variables, we use the letter x to represent numbers. So we are really going to try to look at the 8.4 instead of the 8x4. You may also see 8 and then the letter, or 8 and then the number in parentheses. You should be used to that from PEMDAS and order of operations. We've seen it before. It means whatever that letter is, you're going to multiply it by 8. On the other side, we have a regular division, 8 divided by 4, 8/4, and then something that looks like a fraction, 8/4. Now, looking at the variable expression phrases, underneath we have our first one, 4 divided by a number. We don't know what that number is, so we're going to leave it as n, and it will be 4 divided by n. We have the 4, we have the divided, and the number we don't know is n. Same thing for the next one. 8 more than a number. So this is kind of backwards. We don't know what the number is, so we'll use t. We have our 8, and more than, we're adding to that number. So it's 8 plus t, really. And in this case, since we're doing it backwards, 8 more than a number, the number plus 8. 7 less than a number, also backwards. We don't know what the number is, so we're going to use k to represent. And then less than, we're taking away from that missing number, and we're taking away 7. Finally, 6 times a number. They really kind of give it away every time by saying times. 6 times a number. So what does this all mean? Well, when we look at a problem, it gives us all the information we need. Mike had some baseball cards and his brother gave him 4 more. So we don't know what Mike had. He had some baseball cards, so we'll use the letter B to represent those cards. His brother gave him 4 more. Gave him, we're going to say he added to his baseball cards. And there's what his brother gave him, 4 more. That's what we call a variable expression. It does not have an equal sign. Okay? Variable expressions are very important. They are part of all the variables you will see in the SOL and the benchmark, and they do not have equal signs. Down here we have a multiplication one. 7 baskets or boxes each contain the same number of apples. So we're multiplying 7 times however many apples were in there. On the other side, we have what we call an open sentence, or another word you have seen in math, equation. An equation is something that has an equal sign. Same type of problem, we're just adding an equal sign to it. Now let's look at some other types of problems. This first one says, what is the variable in this problem? Well, to do that, I look at all the answers, and I think about what they're telling me. A says whole number. Do I know what my whole number is? Well, I sure do. It's the number 9. Okay? B says operation. Do I know what operation I have? I sure do. Okay? It is multiplication. So it really has to be D variable is what that letter stands for. This next problem is talking about Kathleen and Gabby. Okay? They kind of give it away right here. They say times. So I'm instantly going to look down into my problem. I know that we're talking about Kathleen, and I know that we're talking about Gabby, but really all of that kind of takes a back seat to the fact that they said times already. But we're going to use K for the number that she has. We know that there's a 15 in there. and that we are doing 3 times that 15 to find out what Kathy has. Once again, they really kind of gave it away. This next problem is talking about Ryan and his hamsters. First of all, it's trying to get us to figure out what the 7 minus 2 actually means. So we have 7, take away 2. This first one, Ryan had 7 hamsters. Each hamster had 2 babies. So we're really multiplying 7 hamsters by 2 babies each, which has nothing to do with subtraction. The second one, we're talking about 7 hamsters, and Ryan bought 2 more at the store. If I'm buying something, I'm adding to what I have. Also not going to work. Third one, 7 hamsters, and they each got 2 treats. Really hard to do hamsters and treats and get an answer, okay? They're looking at how many treats he had overall, so that's not going to work. Finally, Ryan had 7 hamsters. He gave 2 to a friend. If I'm giving away something, I am subtracting it. So that would work. 7 minus 2 equals hamster. So choice D would be correct for that one. For our last question here, we're looking at making an expression here for less than a certain number. Okay, there's a couple different things here. Less than, we're looking at subtraction. So we're going to take away the 4 plus n and the n plus 4, which leaves us with 4 minus n minus 4. Less than a certain number. We don't know what the number is, but we know we're taking away 4 from that number. Okay, the first one is 4 minus a certain number, and the second one right here, a number minus 4, which is what we are looking at. One of those backwards problems that we gotta kind of figure out what they're really asking. Finally, we have one last way they could try to do variables with us, and that's on the mats. Up here we have a key. Our key tells us 1 triangle equals s, and 1 rectangle equals 1. So the problem here is 4 plus s equals 5. So our key here is that our equal sign is in the middle, and we have to have 4 plus s on one side and 5 on the other side. So let's draw out our equal here. What exactly are we looking for? It looks like we're looking at the right side first to try to figure out our 5. So what should it look like? Well, if 1 square or rectangle equals 5, I should have 5 of them there. They're not the most perfect, but I have 5 on this side. And on the other side, I should have 4 plus s. 4 being a number, and s is represented by a triangle. So I have 1 triangle, and then we go back and we see we have 4 rectangles. And again, not perfect, but that's what our representation should look like. 1 triangle and 4 rectangles, and then on the other side 5 rectangles. And really only one fits, and that's right here. We have our 4 rectangles, our 1 triangle, and on the other side 5 rectangles. So there's our choice. This one has 5 triangles. That can't work. That one has 4 triangles. Definitely can't work. So this is all about just matching things up, one side and then the other. Always look for the key. The key will help you. And that really is all of variables.